Dr. R. Manikandan, he has pursued his BE from Civil Engineering from the University of Madras and his Masters in Structural Engineering from Madurai Kamaraj University, and he had his doctorate in Concrete Technology, Indian Institute of Technology, Madras, and he was an assistant manager in the Central R&D Cement Business, Grasim Industries Limited, and he was a manager product development MIC Business ACC Limited, and he was a chief manager new product development MIC Business, and at present he is the head customer service support Technical South Region ACC Limited. His area of research includes manufacturing and characterization of artificial lightweight aggregates, rheology of cement paste and concrete, performance evaluation of concrete chemical admixture, characterization of chemical admixtures, self-compacting concrete, and development of high-performance concrete. His academic associations with university and journals. He is an external examiner for MTech thesis evaluations for IIT Mumbai, doctorate committee member in Civil Engineering Department VIT, Chennai campus, research advisor for Kalsalingam University, Tamil Nadu, research advisor for CMRIT Bangalore. He is a reviewer for International Journal of Engineering and Technology Innovations and ASTM Journal of Testing and Evaluation. He is also a reviewer for Journal of Institute of Engineering. Stage is all for you, sir.
Talk about this sustainability in design to construction stage, how the new methodology has been adopted or thought of designing the structures. This is not my work, and it is basically kind of a review of literatures with some evidence by some famous researcher on this subject. So basically it focuses on concrete and with respect to sustainable construction, how we can think of reducing the environmental impact. So I will not make you sleep. Pardon me. Let us make it some interactive session. My presentation not will be a lengthy presentation. I'll just try to cover within 10-15 minutes. This will give some idea about where we can focus on what we have been thinking conventionally, how we can think differently towards addressing the sustainable construction. Being a cement company, I will be happy to promote more amount of cement, but this approach will talk about differently on that aspect. If you see, people talk about global warming. HOD of NITK said when he joined this institute, that time there was a global warming. He was in, people make fear psycho that this Bangalore will submerge in sea. So this, what is global warming? What are the things which contributes for the global warming? See here, majorly these carbon dioxides, where it comes from. And most of the time, when being a civil engineer, it is commonly has been referred that the CO2 emissions comes majorly from cement. Of course, it's correct, partially correct. But if you look at here, most of the greenhouse gas emission also comes from some other industry as well. These charts are taken from the literature. You see here, the cement industry contributes only 7%. About the total CO2 emission and the greenhouse emission, the 7% comes from cement industry. But of course, if you see the volume of cement which has been produced, it's a huge, million tons. In India alone, we have produced more than 350 million tons per year. And the installed capacity is more than 500 million tons, which is going to increase further. And moreover, you see the cement which is having produced here, and it has been transported to more than 500 kilometers. Which is not required. A cement produced in Kadapa belt is been transported till to Mumbai. A cement produced in Rettipalayam, it has been transported to Hyderabad, which is not required. But of course, when you invest such huge amount of money in the industry, if you want to compete and make your capacity utilization more than 75% to get the return of investment, you have to sell the market where there is a growth. And if you see there, most of the cement companies and being Mr. Narayan being a Keralite, if you see, he was saying the price of the cement price in Kerala is very high. And one of the our dealer asked, your cement factory, I work for ACC Cement, our factory is there near Coimbatore. We produce the cement here in Coimbatore, but you sell it at a higher price there in Kerala, which is just 70 kilometers from the manufacturing unit. Why is that high price? It is, we could not answer, but partially it is, he is correct. When a cement companies from Kadapa will transfer the cement to Kerala, he has to keep it some margin and sell the cement. Obviously, he will keep a higher price. And I have to keep that my price because my production cost is higher because of the various constraints on the raw material quality. So, invariably, we consume more energy by transportation of this material, cement. Cement travels, the cement companies makes more money when he sells the cement within 150 kilometers. He makes a margin more than 20%. If it travels more than 250 kilometers, the margin comes to below 10%. The logistic cost consumes more than 50% of the cement cost, which includes bag cost, transportation, primary transportation, handling, and then you transport to the dealer, and then your dealer sell the cement to the customer, and then there is a third party. There is too much of handling in the cycle. So more amount of energy also been consumed in transportation of cement. So look at here. This is kind of one information which shows that the raw material extraction in terms of, I am talking with respect to cement and cement manufacturing. So if you see there, more than 360 million tons of raw material is being extracted per year. And if you see in terms of, you want to quantify in terms of seconds, every 5 seconds, 55 trucks or closer to 55 trucks are being excavated. And you see this, it has a major impact on the CO2 emissions. And if you see the emissions levels with respect to cement manufacturing, majorly it comes from the fuel what we use for cement manufacturing. Also the raw material, which is limestone. When you burn the limestone, as I said, the calcium carbonate, which is the limestone, when you burn at 700 degrees Celsius, to get the cement manufacturing limestone quality, if you burn that, you will emit approximately 40% of CO2 of this total cement production. And into the volume of the cement production, it gives a more amount of CO2 emissions, which directly impacts the environment. And also, there are some process which is also still we adopt the old techniques to consume the poor quality of limestone, which is actually semi-dry process. Of course, that has been considered as one of the best processes in terms of limestone, cement manufacturing quality consistency. But still, it consumes more amount of energy because basically because of the poor quality of the limestone, which has to be ground and make it as a semi-fluid, and then you by chemical reaction you take out the required limestone and unwanted material is being removed, and then by that process the amount of fuel which is being consumed is more than 3 times of the dry process. So such processes are mostly eliminated in all across India, but of course there are 2 plants in India which is actually ACC adopt that process because of the limestone quality. One is there in Madhukkarai and one is there in plant in Bihar. These 2 plants operate on semi-dry process where the silica content in the limestone is more than 25%, which is actually difficult to react with the lime at a high temperature. So this semi-dry process has been adopted for removal of this highly crystalline silica. And what happens by that process, it consumes a lot amount of water. That water also once you use that water, it has to be drained out because it contains a lot of chemical caustic soda. When it reacts, it also the water also carries some amount of lime and limestone. So that is not been able to recycle it. We face a lot of challenge in recycling of those waters. So a lot of water also been consumed on production of those kind of semi-dry process. Yeah, if you see here, globally, the construction industries consumes more than 10% of the available energy. So, more than 40% of energy. In construction, we consumes more amount of energy during construction or the transportation of material construction. And then if you see the total energy which is actually being consumed in the maintenance of the building. So how to construct the building, and how when they design, if you make a proper design, the most of the energy consumption can be reduced if you have a proper design. That is actually where my next slide shows. You see here, uh, in this, the design stage, there is a potential possibility of reducing the CO2 emission. This is one research article which highlights that the possibility of reducing the emissions uh, in the design stage 1 to 2%, whereas in the manufacturing and the products emits around 15 to 30% of greenhouse gas emissions. Distribution of which I said the logistic part, and then during construction, then major amount of energy is being consumed in the usage as compared to the production of the material or which is being used in the constructions. And where currently what we adopt a technology, where the traditional design, which shows that most of the energy which is being consuming is in the use phase. Whereas you see here in future building, there is a concept which comes there that if you have a proper design in place, proper selection of material, proper construction techniques, which says that, say for example, proper construction techniques. What is the proper construction technique? Traditionally, what we have been using is the frame structures, which have a beams and columns, and then you have a infill walls, masonry walls. If you see that new trends are coming there in metros, that is actually precast, completely precast. One is precast, second is my own construction. In that, if we go for the my own construction, you have a drastically reduced the amount of materials which is being used in the construction, which has a lot of impact on structural behavior. If you see the people have shown the demonstration, more than 13-story building which is constructed with the my own construction in India. Of course, in outside India, people have constructed more than 20-story building. Whereas in my own construction, it is completely just the wall and the slab thickness is just 100 mm, just 100 mm. Whereas if you want to construct a frame structure for 13-story building, your column width is more. And to have, you want to have a masonry wall, minimum people are using 200 mm thickness wall there in the construction. It consumes more amount of natural material. It is not that natural material means only cement consumption. If you consume more amount of aggregates, aggregates also becoming scarce now. It is not available everywhere. People, there are times where the cement sale has come down to 30% in Karnataka because of sand is not available. 30% in 2017. So if you have, you know very well, more than 70% of the concrete volume is occupied by the aggregates, either in form of fine aggregate and coarse aggregate. If you use this material properly, we can save the natural resource. If you, that's what I am saying. In the design stage itself, if you have a proper design selection construction techniques, we can directly save the lot amount of energy, which will lead to the saving in terms of not only on the cost as well as on the environmental impact. Yeah, see here, which is actually, this is for the, if you produce OPC cement, which is, says that around 0.9 to 1 ton of CO2 is emission for a 1 ton of cement production. For production of 1 ton of cement, I need around 1.5 to 1.6 ton of limestone. When you burn limestone, you emit CO2, right? So the CO2 emits means that there is a weight reduction. If I want to produce 1 ton of cement, I need 1.5 tons of limestone. So that approximately 40 to 50% of that goes to the gas, CO2 gas. So basically, mostly we use calcium carbonate based on the lime, which is basically limestone. There are some kind of dolomite limestone also being used. Primarily, it is being used in the steel manufacturing. Mostly, the cement manufacturers avoid dolomite-based limestone. So the traditional, what is sustainability? Traditionally, it says that don't cut the tree, make it green, and then so make construction which is actually more environment friendly, that like mud-based structures. This is a traditional way of looking at the, looking at the sustainable construction. But there are ways where we can reduce the CO2 emissions by having a different approach, like improve the service life of the structure or improve the performance of the structure by how selection of proper material and selection of proper construction techniques. Also maintain the buildings in periodic manner so that it improve the performance of the buildings, which will directly reduce the environmental impact. See here, this is a one concept proposed by one Professor Herald. He says that when you want to achieve the sustainable construction, one has to improve the service life of structure and performance of structure, which will reduce directly the environmental impact. How to do that? So the service life of structure, how to improve that? Make an adequate service life design approach, or you have a regular monitoring of structures, and then if you have a periodically monitoring or repair or rehabilitation of the structure, instead of going for demolition, you make use of the structure. What my previous speaker has said, instead you demolish it, you make use of the structure by having a proper rehabilitation of structure, which will improve the service life of the structure. Of course, the performance, instead of going for the traditional concrete mixed design, which will have M30, M40, you go for high strength concrete, which is based on the particle packing, high strength cement, usage of supplementary cementitious materials, which will drastically reduce the amount of